Hey there, it's Dr. Guerrero. I just wanted to go over the molecules that we built in lab to review you. And if you weren't able to build them or didn't understand one of the concepts, I wanted to cover that real briefly for you. So the first group that I asked or that we asked you to build included the hydrogen gas, water, so H2O, carbon dioxide with its double bonds, then oxygen gas, with a double bond, nitrogen gas being triple bonded, ammonia with nitrogen with 3 hydrogens, and then acetic acid. Then underneath that, we ask that you build functional groups. So the functional groups, we have the hydroxyl, the carboxyl, the amino, aldehyde, and the ketone, making sure you can distinguish between the aldehyde and the ketone, the aldehyde having the hydrogen, additional hydrogen. Then we got to the carbohydrates. So glucose is a monomer, a carbohydrate, so the smallest a carbohydrate can be, and it has the same molecular formula, so C6H12O6 as fructose. So we had you build these, and I want to talk about how you can distinguish between them visually when you see them on your lab exam. So the double bond for glucose, the double bonded oxygen is on the first carbon, so on C1. When we look at the ring structure, the shape in the center, and this again was me as I was evaluating students. So it is a hexagon. So it's not the perfect picture because I'm not a professional photographer, but I did want to give you something to reference. So a hexagon in the center for glucose, and it's double bonded on the first carbon. The oxygen is double bonded on the first carbon for glucose. All right, versus fructose, which is another monosaccharide, but has the same molecular formula, C6H12O6, but it has a different shape, so it has a different function. So I can distinguish this visually when I'm looking at it on the exam because the double bonded oxygen is on the second carbon, and this ring structure is in the shape of a pentagon. So this allows me to visually identify those when I go to study. Then we got into lipids, and that's where we had you build that long palmitic acid and then the glycerol as well. Okay, so this was the most time consuming. But then I asked after that, hey, may you please and thank you dehydrate this. And in class, I reviewed that dehydration is where you remove a water for every bond that you want to form. So whenever you came and demonstrated it up at the front for me, I had you put those two together and then show me the water you removed. But I also embedded a dehydration demonstration video for you here so that you could see it happen as well. So just watching over it, you take a oxygen and a hydrogen from one, and then just a hydrogen from the other. A bond is formed. So now they become one, and then you demonstrate the formation of that water. So you removed one H2O, and it created one bond. So I took two, and I made it into one. Dehydration is the removal of water. Synthesis means to make or create. Then after we dehydrated it, I asked you to take it from being saturated to being unsaturated. So saturated by definition means full. And so if you look at this lipid right here, palmitic acid, in its saturated form, every opening, it has a hydrogen. Everything is full. So saturation means full. This type of fat, when it's circulating through your cardiovascular system or your blood vessels, is straight, it's linear. And so it tends to get caught and then cause occlusions or obstacles, and then eventually blockage. So saturated fats are bad fats. But again, we wanted you to unsaturate it. Unsaturated means make it unfull. So right now it's full of hydrogens here. And what I want you to do is remove some hydrogens. And instead of having them bond to a hydrogen, have those carbons bond to each other and create a double bond. So because it's only unsaturated in one spot, we call it a monounsaturated fat. We can also do polyunsaturated and so on. I did also have a video embedded here where you can see one of my students demonstrating how to unsaturate this lipid. So just taking out those hydrogens. Also removing that single covalent bond. And then replacing it with a double bond. So now it takes it from being linear, where it could get stuck, to having a bent structure, so it's more flexible in circulation. When you're looking at exam questions and it's asking you questions, is it saturated or unsaturated? Ultimately, what I need you to be able to identify is there a double bond? If there's a double bond, there could be 1, 2, 3, then it's unsaturated. But if there are no double bonds within all of those carbons and hydrogens, then it is a saturated fat. And then last but not least, we had you build amino acids, glycine and alanine. Okay, glycine having 3 carbons, and me pointing that out when you were demonstrating, and alanine having 2. Amino acids are the monomers for proteins. And then after you built those, I was like, okay, well, now dehydrate them. So a demonstration video once again of the dehydration of these amino acids. So again, taking a water out, we have 2. We take a water out so we can create 1. You take a hydrogen and an oxygen from one and a hydrogen from the other. Create that bond. So now I have 1, and I demonstrate the formation of that water. Okay. I just wanted to run through this for you so that you could kind of review this content for the lab exam. Don't hesitate to reach out with any questions, and thank you for watching.